Okay, I think I got it now. I think we're good. All right. So so this is question number 2 from the study guide. So just to review the diagram that we just drew, for those that are watching the recording, points A, B, and C are not collinear, meaning they're not on a straight line, and it forms angle BAC. So since A is the center, that means A has to be the vertex. So we started first with the point, we basically made an angle, right? And we have the point B at one end, A at the vertex, and C at the other end. Then we said extend ray AB to point P. So we just drew a line that went from A through B, but past B, and where it ended is where we put the point P. Then we drew the line L that passed through P and parallel to segment BC. We realized we did not have segment BC, so then we drew in the segment that connects B and C. Then the line that goes from P and is parallel to BC looks about like this. This is all just sketching. Added the L and then added the markings to show that they're parallel. One arrow on each. Then it says it, I was talking about it, line L, meets the ray AC at point Q. So extend the segment that starts at A and goes through C past C, and where it intersects line L is the point Q. No, it's great. Q looks great. All right, so there we have, this is the diagram that represents that situation. Yes. Okay, then part B, we'll just go ahead and finish this problem, says, is segment PQ longer or shorter than segment BC? What do y'all think? Kevin says longer. I see the chat box going, so I'll wait. I want to see what you got. Good question. So it is going to be longer. That is correct, Roderick. But parallel lines will keep the same slope, but not necessarily, they don't have to be the same length to be parallel. So it's a very, very good question. So segment PQ is longer than segment BC. We can tell from our diagram, but also if you think about the fact that if we have this angle measure, right, no matter where we are on the angle, it's the same measure. But the distance from ray to ray of the angle gets further and further apart as we, get further away from the vertex. So that's kind of what's happening. In other words, like, what other situation occurred here, so to speak? Ah, yes, you are correct. They are technically parallel segments. Well, we did make segment PQ began with line L. We can also call them lines. And if they're parallel segments, then the lines that contain them are also parallel. Hey, hey, hey. So technically, what happened, do you think, here? Like, what can we call this from BC to PQ? Yeah, technically a dilation occurred because A is your center of dilation, B moved the same distance along P, and then C moved to Q the same, like the ratio is the same. Do you remember when we did this by hand, where we created the line that was parallel, what was that called? Remember, we performed dilations in two methods, two ways? No, we didn't use the auxiliary lines. Yeah, that was something else. We used the two methods to perform dilations. One of them was the ratio method, and that was when we would have said, whatever this length is from A to B, from your center of dilation to the point, the pre-image point, then the distance from A to P, the center of dilation, to the image point, will be the scale factor r times the original distance from A to B. So remember, the scale factor times that give you the distance from A to P. So not only does the scale factor apply to the length of the original segment to get the length of the new segment, it also applied to the distances from the center of dilation to the image point, and the center of dilation, pre-image and then to the image. No, so cross multiplication, we use that to find missing lengths. Yes, we did use that. So no, you're fine. The other method that we used was with the set square. Remember? The parallel method was with the set square. And so the ratio method was basically that the new is equal to the scale factor times the old for anything. Distance from the center and then distance from each point. So this right here, this sketch that we made, basically used the parallel method to dilate segment BC. That's what happened. Because we created a line that was parallel, and that's how we found point Q. All right, how can we prove that triangle ABC is similar to triangle APQ? So let's take a step back. What are the 3 ways to prove that triangles are similar? So Kevin says, I'm assuming you're saying we should use angle on this one. That is very likely correct. I won't say so just yet. But yes, there we go. That's all 3 of them. You can show 2 angles are congruent, or you can show 1 angle is congruent with 2 proportional side lengths on either side, or you can show all 3 sides are proportional. So since we don't have any side lengths, we don't have any angles either, but angles are often easier to find information on. So Kevin suggests that it's probably angle. We do have parallel lines here, and parallel lines do tell us a lot of things about angles. So what angles could we find that the 2 triangles have that are congruent? So just to kind of highlight what we're looking at, triangle ABC, that's the little one. And then in pink, I will do triangle APQ. Like that. So Kevin says angle P with angle CBA, first off. So why do you want to say those 2? Why do you think that angle P is congruent to angle CBA? Yes! Y'all see that? P and CBA are congruent because when parallel lines are cut by a transversal, the corresponding angles are congruent. They have to be parallel for corresponding to work. And then he mentioned BAC is congruent to BAC, or angle A is congruent to itself. See how the differences between when we are able to use 1 letter if we want versus when we can't. We have to use 3 letters. I had to use 3 letters for CBA, but for P and A I could technically use 1 or I could use 3. Doesn't matter because there's only 1 angle there. Why is angle A congruent to angle A? Yes, the reflexive property of equality. Very good. Therefore, triangle ABC is similar to triangle AP. Whenever there's an A after the triangle symbol, it's lucky to be written down. Okay. Triangle APQ due to angle-angle similarity. Now, that's not like a completely formal proof. We would need to begin with like the fact that we did all that construction, and we would need to make sure to mention that the 2 lines are parallel, right? But we kind of have that all before this point. So this is really all we need for our answer C. All right, and then part D. What other pairs of segments in this figure have the same ratio of lengths that PQ has to BC? So I kind of already mentioned that before now. So can you think of any other ratios that exist in there because of this technically dilation that occurred? So you said AB with AP. Yes. Perfect. So let's see, if we're saying PQ over BC, yes. Also, AB over AP, yep. Wait, I have that upside down. Hold up. That's why I wrote the first one, so I wouldn't mix it up. I shall fix it. So since I have PQ in the numerator, that means I need to put AP in the numerator, AB in the denominator. The bigger triangle is in the numerator. Doesn't matter which one goes where, it just has to be consistent. Alright, and then AC and AQ. Perfect. So then I have the smaller triangle down in the denominator. And within each fraction is the sides that correspond, right? Any other ratios that you can think of? Yeah, nope. Those all have the same ratio. Yep, those are all proportional, like in that same exact ratio. There are other ratios that do exist. They just don't divide down to the same number, if that makes sense. So just kind of throw this out here as extra. This is not part of the answer for part D. But you could also say AB over BP would be equal to AC over CQ. That is another one. That's just another one that exists. It doesn't match with the one in part D. It just, is there. You could also say PB over, let's see, yeah, PA. Yep, that one would work as well. With set equal to QC over QA. That just is another, it's just another extra one that exists. Alright, how's that? You check in with me, green check if that's all okay with you. For number 2, red X if anything is unclear. We need to go back over something. Good deal. Okay, I'm going to turn all these recordings off.